Hello students, welcome to Pi Academy, the place for mathematics and science. Dear students, yesterday we started the chapter motion. Now let us go for continuing this. Before that, just we shall recall some important points what we learned in yesterday's class. The very first point, we know that there are two states of a body. Can you recall them? What are these? Yes, you are right. The first one is state of rest and second one is state of motion. Another second important point is state of rest and motion are relative, and we took some of the examples. You may recall the situation regarding these two, as one is train and second one is lift. Next, we come across different types of motion. Among them, we are going to discuss two types of motion in detail. One is a motion along a straight line. It is linear motion. Then if a motion of a body in a curved path, then it is called circular motion. Next, can you tell the specific point which is used for describing the location of an object? Yes, you are right. It is origin. What it is also called? It is a reference point. Next, we have come across many measurable quantities, and these measurable quantities are called physical quantities. There are two types of physical quantities. One is scalar, which has only magnitude. Second one is vector, which has both magnitude and direction. In this chapter, that is the chapter motion, we are going to discuss some of the important physical quantities. Yesterday, we discussed two physical quantities. One is distance and second one is displacement. What do you call the length of actual path traveled by a body? Yes, you are right. It is distance, and its symbol is D. The distance can be measured by a unit called, it is meter. What type of physical quantity it is? It is a scalar. Why? It has only magnitude but no direction. And we also know that distance may be 0, may be positive but cannot be negative. And the distance between any two points may be same or different. These are the information about distance. Similarly, another one physical quantity, it is displacement. The direct distance between the initial position and final position of a body is called displacement. And displacement is denoted by the symbol, it is S. And what is its SI unit? It is meter. Then we also know that displacement may be 0, may be positive, even it may be negative also. And the displacement between 2 points will always be same. Now, in addition with this, some other important points are, what do you name the device that we use to measure the distance covered by a body? Usually it will be fitted in the vehicles. What is that? You are right, it is odometer. And another important point is, under what condition distance and displacement will be same? Yes, it is when a body moves along a straight line, then magnitude of both will be same. Now I am at rest, then what is the distance covered by me? It is 0. The distance or displacement of a body at rest is 0. And even we solved some of the problems on distance. Now let us go for taking some questions from your NCERT textbook. It has been given in page number 100. Now let me go for reading one by one. Just listen carefully. First question is like this. An object has moved through a distance. An object has moved through a distance. Here the question is, can it have 0 displacement? Then sub question, if yes, support your answer with an example. a body has moved through a distance, can it have zero displacement? Certainly. How to say that it is? When imagine that it is the initial position of a body and the body is moving in a circular path, and again it comes back to the same point. So final position. So initial position and final position both are same. Then what will be the distance, the displacement? It is zero. Clear? Now one more, second question. That is also very important in the examination point of view, and very nice problem also. It is related to a farmer. Just go through, please don't copy. After solving this problem, you can pause the video, then you can go for copying it. Let me read the statement. And one more important thing is, when we are reading only, we try our best to understand the whole summary of the statement. It is like this. A farmer moves along the boundary of a square field. Here just we have come to know what is the shape of the field. It is square. Let me draw that. It is a square. Next, of side 10 meter. Each side of that square is 10 meter. In 40 seconds, that means, see, he has moved along the boundary of a square field of side 10 meter in 40 seconds. He has taken 40 seconds to complete one round. If it is so, what will be the magnitude of displacement of the farmer at the end of 2 minutes 20 seconds? 2 minutes 20 seconds. It is the time for which he has moved around his field. I hope that you all have understood. So then after moving for 2 minutes 20 seconds, he will take a position, and that will be his final position. From there, we have to find out the distance from his initial position. Okay, now let us go for solving this. Here, farmer, he has square shaped field. Hence, I will assume let ABCD be a square field. Here I draw it again. See that this is square shaped field. Let us go for naming ABCD. As it is a square, all sides are equal. Then AB will be 10 meter. What about BC, CD and AD? That will also be 10 meter. Here I will write AB is equal to BC equal to CD equal to DA equal to 10 meter. Then he has taken 40 seconds to complete one round. So time taken to complete one round, it is 40 seconds. Then total, what is the total time for which he has moved? Yes, you are right. It is 2 minutes 20 seconds. Here I will write total time for which the farmer has moved. Total time directly I will write. It is equal to 2 minutes plus 20 seconds. 2. Convert. See that these two are different units of time. Make it to 1. Minute is there. How many seconds is equal to 1 minute? It is 60 seconds plus 20 seconds. Now 62s are 120 plus 20. It is altogether 140 seconds. So he has moved for 140 seconds. But how many rounds he has completed? Why should we find out the number of rounds he has completed? Because after moving for 140 seconds, he will come to a position to find out that. Here I write calculation. It is number of rounds completed in 140 seconds. Here I write total time he has taken 140 seconds. To complete one round, he has taken 40 seconds. Here it is. 40 seconds. Now 0, 0 get cancelled. So 2. 2 is a 4. 2. 7 is a 7 by 2 is nothing but 3.5 rounds. He has completed 3.5 rounds. After completing 3.5 rounds, where he will stand? So it is possible to find out when you know his initial position. Which is his initial position? It may be A, B, C or D. I go for taking A. Here I'll write, let the initial position of the farmer, let the initial position be, call it as A. Then after completing 3.5 rounds, you just observe the figure. Now, how many rounds? 1, 2, now 3. Now 3.5. What is his final position? Yes, you are right. It is C. So position of farmer after 3.5 rounds is at C. Now you are going to find out the distance of his final position from, that is nothing but displacement of his final position from his initial position. That means you are going to find out AC. How do you find out AC? Yes, AC can be found out by using Pythagoras theorem, because we have got a right triangle. ABC is a right triangle. Here on right, in triangle ABC, angle B equal to 90 degree, then by Pythagoras theorem or Pythagoras property, you can write the square of hypotenuse AC square is equal to sum of the squares of other two sides. That is AB square plus BC square. What is AB? AB is 10 meter. So 10 whole square. What about BC? That is also 10 meter as it is square shape. 10 square is 100. 10 square means 10 tens are. Here for the sake of understanding, here I'll write 10 square equal to 10 into 10, which is equal to 100. Plus 10 square, 10 square. Sorry, here again 10 square, this is 100. You can write it directly. How many times 100? 2 times. You can write 2 into 100, or else 100 plus 100 is 200. Now AC square equal to 200. What about AC? AC is square root of 200. And square root of 200 can be written as 100 into 2. As it is root, there must be one perfect square. Then it will be easier to simplify. What is square root of 100? It is 10. Square root of 2 as it is. I hope that you have understood. If not, again here I'll write. Square root of 100 into 2 can be written as root 100 into root 2. Where root 100 is 10 and root 2 as it is. So AC is equal to 10 root 2. This is the displacement of the farmer after 2 minutes 20 seconds. So let me write the conclusion here. Therefore, the displacement of the farmer is 10 root 2 meter. So it is an important question, maybe to be asked in the examination. Please do practice. Now in this blue questions, we have one more question is there. Just listen to it. After completing this, you can copy, so you can pause the video, then you can go for copying it completely. Third question is like this. It is just like yes or no question. Which of the following is true for displacement? What is displacement? The distance between, or the least distance between, or the minimum distance between the initial position and final position of a body. The question is like this. It cannot be 0. Here telling that displacement cannot be 0. What do you say? Displacement can be 0, no? So then whether statement is true or false? The given statement is false. Got it? Second question. Its magnitude. Whose magnitude? It is displacement. Displacement magnitude is greater than the distance travelled by the object. So displacement, it is always smaller than the distance travelled, or it may be equal to distance travelled. It cannot be greater than the distance. Hence, the given statement is false. Both A and B are false. Got it? So now let's move on to the next part of the chapter. Before that, please pause the video, then copy this problem. Okay. Dear students, now I am going to give you some of the examples for the motion. Listen carefully and just try to guess what I am going to tell you next. The examples are, here a car is moving. It is covering 4 meters for every 2 to seconds. Second one, we know that Earth revolves around the Sun, and to complete one round it takes 365.25 days. Maybe first year, second year, third year, whatever it is. And also just recall the movement of the arms of the clock. Maybe the smaller one, hour clock, hour hand, minute hand, or second hand. Okay, these are in one part. I am going to give you some more example. Now, in these examples, the first one is, you are riding the bicycle in the marketplace. Second one, you are moving to the school. The school is approaching. Then the motion of your bicycle. Then third example, then some persons are standing nearby the bus stop. The bus is coming and it is approaching the bus stop. Observe the motion of the bus, motion of the bicycle in both the cases. Then I hope that you are able to guess what I am going to tell in these two parts of examples for motion. Yes, in first part, whatever I took, the earth, maybe the clock, maybe the car, in all these cases, the body is covering equal distances in equal intervals of time, right? And we call such motion as uniform motion. Once I tell the definition, if a body covers equal distances in equal intervals of time. In second cases, that is, you were riding the bicycle in the marketplace there, and the bus is approaching the bus stop. In these cases, the body is not covering the equal distances in equal intervals of time, and we call the motion of such bodies as non-uniform motion. Once I tell the definition, if a body does not cover, or if a body covers unequal distances in equal intervals of time, or equal distances in unequal intervals of time, then the motion is said to be non-uniform. Clear? So now let me show you some of the examples with the chart. You just observe them. Here again I have taken the same, the car. You can notice that it is A, B, C and C, E and F. These are all the positions of the car. And the distance has been mentioned, 0 meter at A, at B 4 meter, at C 8 meter, like that it has been continued up to 20 meter. And to cover the distance from A to B, how much time it has taken? 2 seconds. What is the distance from A to B? It is 4 meter. What is the distance from B to C? That is also 4 meter. Time taken 2 seconds. See that. To cover equal distances, it has taken equal interval of time. Therefore, you can say that the car is moving with uniform motion. Right? Next, similarly, you can take these two examples. The movement of the hands of a clock. See that here, minute hand is there. After completing 60 minutes, it comes to the same, like this. Or else, to cover these numbers, every time it will take 5 minutes. So it is also covering equal distances in equal interval of time. Next, similarly, the movement of the leaves of the ceiling fan, here also these are covering equal distances in equal intervals of time. Hence, all these are examples for uniform motion. Next, I go for taking another one. Here, boy is riding the bicycle in the crowded area. Then, here is the bus which is approaching near the bus stop. Bus speed, it will be changing. So, it will be covering unequal distances in equal intervals of time. That is, for every 1 second, the distance covered by it will be differ. Hence, we can say that it is an example for non-uniform motion. Even this is also. What about this? Here, the ball is dropping. A ball is dropped from some height. Will it cover equal distances in equal interval of time? No. Even when the ball is thrown, see, beginning we feel that it is going up faster. Then by the time as it goes up, the distance covered will go on decreasing. So all these are examples for non-uniform motion. So now let me go for writing the definition of both with example. You have to copy. Dear students, here I have written the definition of uniform motion as well as non-uniform motion with examples. Please copy them. And in this I have included two important points. Uniform motion, it is non-accelerated motion, and non-uniform motion is, it is accelerated motion. You may be having the experience that suppose when you are sitting backside of your parent who, particularly your father who is riding the scooty, then sometimes they will go for rising, that is giving the acceleration. There the vehicle will be moving with non-uniform motion. Okay. Now you have to pause the video and should copy the whole. Okay. Dear students, now I am going to teach you another physical quantity, but I don't want to tell. But I give you some of the examples related to it. Try to identify. We are very familiar with some of the famous sports person. One is P.T. Usha, second one is Hima Das, third one Usain Bolt. And also one of the traditional game which will be held in Tamil Nadu called Jallikattu, where the sports person will run behind the bull to catch it. Then another one of the famous sports which will be held in Karnataka, that is Kambala. There the sports person will run along with the fast moving buffaloes, right? Now can you guess what I am going to, which physical quantity I am going to introduce now? Yes, your guessing is right. In all these cases, the persons are moving as fast as possible. That means their speed will be considered to achieve their goal. So the concept of the physical quantity that I am going to introduce is speed. Correct. Now I will go for taking one more example. One of the famous Indian bowler is Bumrah. When he comes for bowling, on the TV screen they show that 145 kilometer per hour. Do you know what does it mean? Yes, it means that whatever the balls will leave, this ball is able to travel 145 kilometer in 1 hour. It covers 145 kilometer just in 1 hour. That much speed will be there. Dear students, now let us get more information about speed under the heading rate of motion, or measuring the rate of motion. Measuring the rate of motion in under this. First one is speed. Then what is speed? Here, whatever the amount of distance may be covered by a body, if it is calculated for unit time. Suppose you go for you are traveling from your house to your school. The distance you cover is about 900 meter. To cover 900 meter, you have taken about 50 seconds. 50 seconds. Now, you may be going by a vehicle also. Now, could you tell in 1 second what distance you have covered? To do that, you can go for dividing 900 meter by 50 seconds. 0, 0 get cancelled. Then 5. 1s are 5, 4 will remain. 4 will remain. It is 40. 5. 8s are 40. So 18 meter per second. So that is the speed with which you have moved to the school by vehicle with your parent. So here, what does 900 indicate? It is the distance, and 50 indicates it is the time. So the distance traveled by a body in the unit time is called speed, or the rate of distance is called speed. Let me go for writing the definition. Write it quickly. The distance traveled by a body, distance traveled by a body in the unit time is called speed, or the rate of distance means distance covered is to be considered for the given time. Rate means the time should be considered. The rate of distance traveled is called speed. And we have a formula to find out speed. I am going to write the information. Speed formula. Speed is equal to distance traveled divided by time taken. Symbolically, it can be written as speed is denoted by the symbol V. Distance traveled, it is D, and time taken is small t. So V equal to D by T. Now, then what is the SI unit of the speed? SI unit, System of International Unit of Speed. Using the formula only you can go for writing. Here I will write SI unit is, what is the unit of distance? It is meter. Unit of time? It is second. Hence we can write meter per second. And symbolically it can be written as M or S, or M S raised to the power minus 1. When you are moving with some speed, do you consider the distance towards, do you consider the direction? We won't consider. So hence we can say that speed has only magnitude but no direction. What type of physical quantity it is? Yes, it is a scalar quantity. Here I write, it is a scalar quantity. Then one more important information, that is the speed of a moving body or moving vehicle can be found out by using the device that is called speedometer. Speedometer. So this is the information about the speed. See, it is possible to use this formula if and only if the body moves with, if a body covers equal distances in equal interval of time. That is what we say uniform motion. Suppose a body covers unequal distances in equal intervals of time. Example, a man is riding a bicycle. He covers first 10 meter in 5 seconds, next 10 meter in 7 seconds, next 10 meter in to just to 3 seconds, like that. Here equal distances are there, different time has been taken. Under such condition, we go for calculating the average speed. The average speed is the ratio of total distance traveled to the total time taken. So let me go for writing that. Average speed, this is the ratio of total distance traveled by a body to the total time taken, to the total time taken is called average speed. Average speed is denoted by the symbol VEV, average speed. Total distance, I told you, in different distances, different time will be taken. First, they cover a distance, I call it as D1. Time taken to cover the distance D1 is T1. Next, second distance D2. And next time taken is T2. Then D3 and so on. Dn. And here also T3 plus so on plus Tn. So this is the formula used to find out average speed. Okay. Now assume that a body moving along a straight line. Can you give some examples? Suppose if 100-meter track is there, usually the sports person will run along that track only, right? They move in particular direction. And light, we know that light travels in a straight line. Anyhow, in these two cases, the body covers some distances in the unit time. As the body travels in a straight line, then can we say that it is displacement? Yes. So then the displacement of a body in unit time is called velocity. Velocity is the displacement of a body in the displacement of a body in unit time. Or else you can also tell like this: velocity is nothing but speed with direction. In case of speed, we won't consider the direction, but velocity, direction must be considered. So now let me give you the information about speed and velocity. Now you are going to copy this one by pausing the video. Yes. Now we are focusing another physical quantity. It is velocity. And I have already given you the example for velocity. If the speed of a body is considered with the direction, that is called the velocity. And one of the example for this is the velocity of light. It is more suitable to say velocity of light is 3 lakh kilometer per second than speed of light. Speed can also be used, but with the direction should be mentioned. Now here I have written the definition of velocity. The displacement of a body in unit time is called velocity. It can also be defined as the rate of displacement or the speed of an object moving with a definite direction is called velocity. And the formula that we use to find out velocity is displacement divided by time taken. So V equal to S by T. When you know just displacement and time, you can go for using this formula to find out the velocity. And its SI unit also can be found out like in speed. Displacement unit is meter and time is second. Therefore, SI unit of velocity is meter per second, or symbolically m per second, or ms raised to the power minus 1. So meter per second is the unit of speed as well as velocity. Therefore we can consider that is the SI unit as similarity of speed and velocity. Now, as we consider the direction also in case of velocity, hence we can say that it is a vector quantity. Velocity is a vector quantity. Why? It has both magnitude and direction. A body moving in a straight line, then displacement can be considered. If in the straight line, if it is covering equal distances in equal interval of time, then you can say that it is uniform motion, is nothing but uniform velocity. Under such condition, the average velocity can be written like this: VAV is equal to U plus V by 2. It is uniform rate. Average velocity can be defined as the arithmetic mean of the initial velocity and final velocity of a body. It is possible in case of a body moving along a straight line covering equal distances in equal interval of time. Now another case, a body is moving in a straight line but covering unequal distances in equal intervals of time. Under such condition, you can go for taking like this: average velocity VAV, again VAV, it is total displacement to the total time taken. Once I repeat, the average velocity is the ratio of total displacement of a body to the total time taken. Hence, it can be written as VAV equal to S1 plus S2 plus S3 plus so on plus Sn. And time to cover first displacement T1, second T2, like that. It will be continued up to Tn. Here, in this formula, don't forget these two new terms. U is initial velocity and V is final velocity. Hence, average velocity can be defined in terms of these two as the arithmetic mean of initial velocity and final velocity. Arithmetic mean of initial velocity and final velocity. Okay. Now, in the examination point of view, the question can be asked like this: write the differences between speed and velocity. So you can write like this: here speed, here velocity. You have to make two columns. Speed is the distance traveled by a body in unit time. Velocity, the displacement of a body in unit time. Then formula, here V equal to D by T. Here formula D equal to S by T. Then what type of physical quantity it is? It is, and that is speed. It is a scalar quantity. Velocity, it is a vector quantity. Then speed may be 0 or positive, whereas velocity may be 0, positive or negative. Got it? And what is, could you tell under what condition the speed and velocity of a body will be same? Yes, you are right. When a body moves along a straight line, example, the light travels in a straight line, then the speed of light is equal to velocity of light. Clear? What is the similarity between speed and velocity? Both have the same unit, that is meter. SI unit of speed and SI unit of velocity, it is meter. Clear? Now, to measure the speed or velocity, we go for using different units. Here SI unit we have written meter per second. Likewise, kilometer per hour, kilometer per second, meter per minute, kilometer per minute. But among these, we go for using two common units. They are, one is either meter per second or kilometer per hour. If it is so, there must be a relationship between these two units. Now, let me go for teaching you that. Let me write that point here. It's very important. Relationship between one is the units meter per second and kilometer per hour. Very important one. Here I'll take 1 kilometer per hour. Then here another unit is meter per second. Which one of these two is bigger unit? Kilometer per hour. So therefore I'll convert this into smaller unit. 1 kilometer. Kilo means how much? It is 1000. 1000 meter. You are very familiar with some of the prefixes like kilo, mega, giga, tera, and these are. Here kilo. Kilo means 1000. R is there. Convert this into second. 1 hour equal to how many minutes? 60 minutes. Then 1 minute is equal to how many seconds? 60 seconds. 1 hour is equal to 60 into 60 seconds. The calculation will be easier, so that I have written like this. Here 0, 0, 0, 0 get cancelled. 10 by 6, 6 are 36. Now 10 by 36 can be cancelled by 2 because both are even. 2 how much are 10? 5 are. 2 how much are? It is 18. So 5 by 18. We can write 1 kilometer per hour is equal to 5 by 18 meter per second. Very important relationship. This can also be written like this. Here kilometer per hour is expressed in terms of meter per second. If you want to express meter per second in terms of kilometer per hour, just take the reciprocal. Reciprocal is 18 by 5 kilometer per hour. That's all. Got it? So dear students, now you have to pause the video and should copy whatever I have written up to here. Now we will go for solving some of the problems. Yes. Dear students, just we shall move on to some simple numerical problem. Very simple. First I am going to take very simple problems. Observe them. Please don't go for copying this. Here in the very first one, just we came to know how to convert kilometer per hour into meter per second or meter per second into kilometer per hour. Based on that, I have taken one example here. The question is convert 80 kilometer per hour into meter per second. Here 80 kilometer per hour. It should be converted into meter per second. I'll write 80 as it is. What is 1 kilometer per hour in terms of meter per second? Just we had written it is 5 by 18. I'll write the same. 5 by 18 meter per second. Now you just go for cancelling it. Here 2 9s are 2 40s are. It is 45s are 200 by 9. Then you can convert this into mixed fraction as you just go for dividing 200 by 9. 9 2s are 18, 2 will remain, carry down. 0 you will get 9, again 2s are 18, 2 will remain. Hence it can be 200 can be written as it is 22 2 by 9 meter per second. And another simple example, this is also convert 108 kilometer per hour into meter per second. This can be written like this: 108 kilometer per hour. It's equal to 108 as it is. What is 1 kilometer per hour? It is 5 by 18 meter per second. 18 ones are 18 almost are 18 5s are 90 and 6 are. So 6 5s are 30 meter per second. So 108 kilometer per hour is equal to 30 meter per second. I hope that you have understood. Now let's move on to another problem. This is also very simple. If a bus covers 350 kilometer in 5 hours, then what is its speed? Here observe the data. What does 350 indicate? It is the distance covered by the body, that is V equal to 350 kilometer, and 5 hours it has taken 5 hours, that is time, 5 hours, and you are going to find out the speed. In calculation, what is the speed formula? Recall it. V equal to d by t, where d is 350 and time is 5. Cancel it. 5, 7s are 35, then 0. So 70 kilometer per hour. Unit, writing unit is very important. Conclusion. Therefore, the speed of the bus is 70 kilometer per hour. Got it? Okay, dear students, you have to pause the video and should copy these 3 problems. Now, before going to conclude the class, just I'll remind you one important thing. Whatever we have covered today, please practice them today itself. Don't keep anything pending. And second point is, we have learned important concepts. They are one formal problem on distance and differences between speed and velocity. So these two are to be learned, practiced properly, because these two are very important in the examination point of view. So with this, let us stop. Thank you.